All right, welcome to a video of Math with Marcus. Thanks for joining. I'm Mr. Marcus, and let's get into the video. Today is going over the practice test that we did in class. So this practice test was for the sixth grade math standards. So sixth grade expressions and equations, standards 2, 3, and 4. So standard 2 is evaluating algebraic expressions. And the first question went like this. So it gave you 3 diagrams, and they're all composite figures except this one. This is just a rectangle, diagram B. And it's a rectangle with a length of unknown, right? A length of S, right? It's some side length. And then the width is 4. So to find the area of a rectangle, right, you just do length times width, right? Length times width. So it would be just S times 4 or 4 times S. So which of these diagrams here has that as the expression? So if you look here, 4S is 4 times S, right? To find the area here, we would do 4 times S, which matches here, which is just 4S. So diagram B is just 4S. Now, diagram A, it's 4 identical squares, right? I know these are squares because it's a length of S and S, right? If this is like 3, it's a 3 by 3. These could be 5 by 5. But whatever they are, to find the area of this shape, we would do S times S. And if you look, right, none of these two have that. Well, that's interesting. It's here because what we've got here is it's 4, right? S times S, another way of writing S times S is S to the power of 2, right? So I could rewrite this as this is S to the power of 2 or an S square, and these are all S squares. How many S squares do we have? Oh, there's 4 S squares. So that's what we have here. We have 4 times S square, right? 4 of these S squares. 4, so this is another way of writing 4 of these S squares. All right, so that is diagram A, leaving us with diagram C. It has to be the last one, but let's talk about why. So this inner rectangle here, this square, right, it's another S by S. So S times S would find us the area of this. So S times S is S to the power of 2, so or S squared, right? S times S is S to the power of 2. And then these are all just 1 squares, right? 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So we have an S square plus 4 ones, which is exactly what we have here, an S square plus 4 ones, which is diagram C. All right. Now what they wanted to do is just say, okay, hey, well, what if we know that the side length is 3? What if S is 3? What if these are all 3s here, right? The length of each side is 3 here. All these sides here are 3, right? What if this is 3 here? What if these are 3s? Just getting over a cold now. All right. Well, what we could do is we could just use the expression and just plug in the value, right? If we know that the side lengths are 3, we just plug that in for our S. So the first step to evaluating expressions, and this is the entire learning target right here, 6.EE.2 is your ability to do this here, what we're doing right now. Okay, this was just kind of good for your brain. Okay, matching up diagrams. This is the learning target right here. Right here, calculate the area when S is 3, when the side lengths are 3. So step 1, you rewrite the expression. This is the steps I'm going to ask you to do on your test. So rewrite the expression, but you substitute. This step is called substitution, okay, where you sub out the variable, right, just like a soccer team, right? When you sub someone out, there's an empty space on the field until you sub in the other player to take its place, right? So we're subbing out the variable and subbing in, right? Here's the switch, right? Take out the S, put in the 3, right? So swap out the S for the 3. S is 3. The side length is 3. And then you follow the order of operations, all right, to simplify. All right, so order of operations, we've got parentheses, exponents, multiplication, and division, whichever is first in the problem, and then adding and subtracting, same thing. Parentheses, nothing to do inside the parentheses. So you go to exponents. Exponents 3 to the power of 2. Right? 3 to the power of 2 is 3 times 3, not 6. It's 3 times 3. So that's 9. And then you rewrite. And then 9 plus 4, 13. So when S is 3, the area of this shape here would be 13 squares. Right? Because we got 3 times 3. Right? So 9 squares here. So 9 plus 1, 2, 3, 4. 9 plus 4 is 13. Okay, area is 13. What about this shape? What about this one here? Well, just visually, right, if these are 3's, right, 3 times 3 is 9. And then 9 plus 9 plus 9 plus 9, 4 nines is 36. Okay, let's prove it here. Step 1, substitute. So rewrite the expression, sub out the variable, sub in the value, which is 3. Order of operations, nothing to do in the parentheses, so do the exponents first, do not multiply. Exponents first, 3 to the second power. So 3 times 3 is 9. All right, so we got 9 here. And then 9 times 4, right? 4 times 9 is 36, which we already knew. All right, 36 square units. And then the last one, easiest one here, just the area of this rectangle, right? It's a 4 by 3. 4 times 3 is 12. The area of this shape is going to be 12. But let's follow the steps. So rewrite the expression, sub out the variable, sub in the value, and 4 times 3 is 12. Use the parenthesis here, because if you don't use the parenthesis, I see too many students do this. I see too many students do 4 and then just put the 3 in there, and it just looks like 43. That's not what it is. It's 4 S's. And 4 S's is 4 3's in this case. 4 3's are 12, right? 3 plus 3 plus 3 plus 3 is 12, right? 4 3's is 12. So the area here is 12. So that is the standard for evaluating algebraic expressions. Now here is the level that you're going to be asked to do it to, right? What if the variable, right? What if the value of the variable is a fraction, right? What if S is 1/2? So it just says, hey, Habib just drew a new diagram. It's got an area. It's got an area of 6 plus 4s squares, right? So we just made up a new diagram. Now, if you're interested, what Habib did is he took this diagram, right, our 4s squares, and he just added on the little 1 by 1, right? He added on a little 1 by 1 square to each of these places on the corners, right? So that's Habib's diagram, in case you were interested. Okay, that's what he did. He just added on 6 1 squares onto that diagram. Okay, and he's saying, hey, well, what's the area of that diagram when the side length, when the unknown side lengths here are not 3 anymore, but are 1/2? So let's plug it in. Step 1, rewrite 6 plus 4s square. Sub out the variable, put in the value. All right, sub out the variable, plug in the value. The value is 1/2. Okay, order of operations, parentheses, exponents, multiply, divide, add, subtract. So we're here now. Nothing to do inside the parenthesis, so we're good with there. Now we go to the exponents. There are exponents right here. Here's the exponent, the power of 2. So we're doing 1/2 to the power of 2. Over on the side, right, we're going to do this over on the side up here. So 1/2 to the second power is 1/2 times 1/2. And 1/2 of 1/2 is a quarter, right? A half times a half is a quarter, or just multiply across, right? That's how you multiply fractions. 1 times 1 is 1, 2 times 2 is 4, and we've got 1/4. So what do we have here? We've got 1/4, but that is times 4. We have 4 of those, plus 6. Okay, done with parentheses, done with exponents. We're now on multiplying and dividing, and I see that here, right? This is what we're doing. We're multiplying and dividing. So 4 1/4. We have 4 1/4, or 1/4 4 times. Either way, 4 1/4 make 1 whole, right? That's 4/4. So this is just 1 whole, right? 4 1/4 is just 1 whole. Plus 6. If you weren't sure, you should just real quick, if you're not sure why that is, right, let's write it just like this. 4 times 1/4. And you can put the 4 over 1, right? And then multiply across. 4 times 1 is 4. 1 times 4 is 4. And you get 1. Okay, all right. And then 6 plus 1, 7. So what is the area of Habib's diagram when S is a half? The area of this diagram would be 7. Okay, so that is, I think, all of learning target. Let's look at the next page. What you would call level 3. This is the level 3 work right here for this learning target. Here you go. So this was kind of some pre-work. So this is the level 2 stuff. You got to know exponents. So here's 4 expressions: 4 to the power of 3, 3 to the power of 4, 4 times 4 times 4, and 3 times 4. So circle 2 expressions that have the same value. Show or explain your thinking. So 4 to the power of 3 is equal to 4 times 4 times 4. 3 to the power of 4 is 3 times 3 times 3 times 3. Those are not equivalent. 4 times 4 times 4, though, is what we already have written here, right? It is this here, right? These are equivalent. So this, the ones in blue, are going to be our equivalent expressions. 4 to the power of 3. And then 3 times 4 is 3 fours. So that would be 4 plus 4 plus 4, which is not the same as the other ones. So 4 to the power of 3 is equivalent to 4 times 4 times 4. So we kind of showed our work up above. Okay, so those are the 2 expressions. And so the exponent says how many 4s are being multiplied. So 1, 2, 3. The 4, right, is called the base, and that's the number that is being multiplied by itself that many times. All right, exponent, how many times the base is being multiplied by itself, and then the base just says what number is being multiplied. So here we've got the base. Here we have a base of 5, and it's to the power of 4. Right, so 5 to the power of 4. So it's 5 multiplied by itself, 5 times by itself, 1, 2, 3, 4. So 5 multiplied by itself, 1, 2, 3, 4 times. So that is the expression 5 to the power of 4. 5 times 5 times 5 times 5. Okay, so that is 6.EE.2. All right, evaluating algebraic expressions. My dog Bodie was just digging in the dirt outside. I don't know if you can hear Shay yelling at him because he's a bad dog. He's not a bad dog. He's just a dirty dog. All right. Okay, so 6.EE.3 and 4, algebraic expressions. Here is the next learning target. So can you write and identify equivalent expressions? All right. So which expression is equivalent to this expression here? We did a whole lot of work, and I'm kind of disappointed in this problem because we did a lot of work with dividing out, factoring out the greatest common factor. And I knew a lot of students that did this problem identified that, hey, you know what? The GCF here between these two terms is 6. And so dividing out the 6, right? 6 times something is 30, and 6 times something is 6Ds, right? 6 times 5 is 30. 6 times D is 6Ds. So the expression that should be the answer choice down below is 6 times 5 minus D. That is equivalent to what we have because 6 times 5 is 30 minus 6 times D is 6D. This should be the expression down below that I would have wanted them to have as an answer choice. It's not on there. So they must have factored out another number, right? If they factored out a 2, right? If they factored out a 2, both of these do divide by 2. Let's just test what happens, right? Well, I guess we could talk about the first one, right? Does this have a factor of d? This does. So we could divide out a d from just this one. But since this doesn't have a factor of a d, we can't divide out a d from both of these, right? If we multiply it back in and test it, does d times 30 equal 30? No, that equals 30 d's, right? D times 6 does make 6 d's, but it does not make that one there. All right, what about the next one? Here is an order issue that yes, if we divide out 2 from both of these, a factor of 2, right? When we divide out a factor of 2 here, we do get 3 d's, and divide out a factor of 2 here, we do get 15. So this does work, except the fact that they're switched, the order is switched. And subtracting, you can't just switch the order. It has to stay in that order. So if you do 2 times 3 d's, that's 6 d's, but it's supposed to be 30 in the first term. And then 2 times 15 is that 30, but it's in the back. It should be in the front. So this one is just switched. So this, you can't factor out d. Both terms don't have d's. Here they switch the order, so not that. Here is the most common mistake, is that when they go to distribute, they only distribute to the first term and say 3 times 10 is 30 minus 6 d's. Oh, that's equivalent. Well, no, because you also have to distribute to the other term too, to both terms. That's the distributive property. So this is equivalent to 30 minus 18 d's, which is not what we have, leaving us with our correct answer choice of this one, right? When we divide out a 3, from here, we get 10. When we divide the 3 out from here, we get 2 d's. You can just test, right? Multiply in, I'll use the green. Does 3 times 10 equal 30? Yes. Does 3 times 2 d's equal 6 d's? Yes. The minus is there. It's a minus. We're good. That is the equivalent expression using the distributive property to prove it. So what they're asking us to do now is just to use the distributive property here. So use the distributive property to write an equivalent expression for 7 times 4 minus m. So this is 7 groups of 4 minus m's. That's how this is read. 7 groups of 4 minus 7. So it's 7 of these, it's 7 of these, minus 7 of these. So 7 4s minus 7 m's. That's what we've got. And now we just have to simplify, right? 7 4s is 28 minus 7 m's is 7m. We can't combine those terms. Constant terms are not like variable terms. They're unlike terms. Okay, m's can be combined with other m's, but constant terms cannot be combined with variable terms. This does not equal 21 m's. You got to stop there. All right, so simplify the expression by combining like terms. Last problem. Thanks for sticking with us. So what we've got here is I would love to add these all together and make one thing. Unfortunately, we can't do that until we know what the x's are. Until we know their value, we have to leave them separate from the constant terms. What I can do, though, is take these constant terms I'm going to do in red. So I can take these constants, this 12 and this minus 5, and combine those. And then combine the variable terms. I've got this plus 6x, right? Just positive 6x. And this minus x here. So I'm going to combine those. So I've got 12 plus 6 of something we don't know, but then minus 5 and then minus an x. So we're going to combine those. Now, if you do want to use the commutative property, the key here is you have to bring, if you're going to use it, you've got to bring the minus 5 all the way up to the 12 and the minus x with the 6x's. So think of it as just 12 minus 5, and we have 6 x's minus an x, right? So 12 minus 5. So 12 minus 5 is that constant term. 12 minus 5, and we've got those 6 x's minus an x. 12 minus 5, we could use the associative property now. We could say, hey, you know what? I want to add the constants with the constants and the variables with the variables, right? And then we've just got one constant term here, and we've got one variable term here, and this is where the simplifying comes in. It's called combining like terms. 12 minus 5 is 7, and then 6x's minus an x, 5x's. And that's as far as you can go, because like we said in the problem before, you can't combine variable terms with constant terms, right? One of our vocabulary words from early on in this unit. So we've just got 5x's plus 7 or 7 plus 5x's, right? Usually you see it with the variable term in front, right? We could just use the commutative property to rewrite it, but they're equivalent expressions, right? These two are equivalent expressions, okay? There you have it. So that is the algebraic expression 6.EE.3 and 4 using the distributive property, and then combining like terms. So those two are what we're looking at for that learning target there. Thank you so much for joining on the video. Hope it made sense. If you liked the video, feel free to leave a comment. Comment on how amazing math is. Actually, honestly, in any of these videos, if you want to see a special problem done from homework or a skill that you want more help on, you can leave a comment in the video, and I'll try to make a video for you. So thank you very much, and I will catch you guys in the next one.